All right, we're here with our last section in this chapter. We're looking at second and higher derivatives. So we're going to look at how to find them, what their notations are, and what the meaning of these functions are as well. Although most of the meaning part is really going to be saved for the next couple of chapters where we talk about why we're taking these derivatives and what they really mean. So we see here, given a function f of x, the derivative f prime of x is referred to as the first derivative. That's what we've been spending all of our time with so far. But if we're looking for the second derivative of f of x, it's the derivative of f prime of x. But a better way to write that is f double prime of x, or y double prime. Or you could also read it as d2y by dx squared. That's how we read it there, as you see in the bottom there. d2y by dx squared. And what we see here is that we're taking the derivative of dy dx. That's why we said it's the derivative of the first derivative. So that's our notation. And basically all it means is that we're going to be taking the derivative twice. It sounds more complicated than it actually is. So if we're looking for f double prime of x for this function f of x, all we're going to do is first we're going to find f prime of x using our basic rules there. X to the third becomes 3x squared, and negative 3x to the negative first becomes 3x to the negative second. Obviously, we would not like to leave it as a negative 2 exponent, but for right now, it's okay because we're still in the middle of the problem. So here we have f prime of x. Now take the derivative of that. And we see here we have 3x squared. The derivative there is just 6x. And when we have 3x to the negative second, that's going to become negative 6x to the negative third. And then go ahead and move your x to the negative third to the bottom to get your final answer, your final second derivative as 6x minus x to the third. Now, again, this will become more important as we move forward, but if you notice, you see the original function is a cubic, then the first derivative has a order of 2, and then the final one, the second derivative, is to the first degree, right? And that'll become more important as we move on. So we're just taking the derivative of the derivative, and that's how we find the second derivative. Now, since we can continue to differentiate to obtain higher derivatives as well, we could find f to the third of x. We could find all the way out to f to the n of x, or dny over dx to the n. That would be the nth derivative. We could do this as many times as we want, or I should say as many times as the function allows, because if it starts out as an x squared, the derivative is to the x, the second derivative is a constant, and the third derivative is going to be 0. And any derivative beyond that, well, doesn't really exist. All right, so let's look at one that's a little bit harder there. It says here f of x equals the cosine of 2x, and we're trying to show that the third derivative when x equals pi over 8 is 4 round 2. So obviously this is a multi-step problem. We not only have to find that third derivative, but we also then have to plug in what the x value is going to be. So hopefully you recall that when you have the cosine of 2x, the derivative of that is going to be negative 2 times the sine of 2x. And now we're going to take the derivative of that as well, and that's going to be negative 4 times the cosine of 2x. That's the second derivative, but again, we're looking for the third derivative here. So we'll go just one more here, and we get 8 sine of 2x. If you're having trouble with those derivatives, go ahead and take a look back at the previous sections to help you out with that. Now we're going to come in and we're going to plug in pi over 8. Okay, so we're really looking at 8 times the sine of 2 times pi over 8. Obviously, 2 times pi over 8 is pi over 4. So we want to think back to our unit circle, where pi over 4 is here in the first quadrant. Our reference angle is pi over 4. We should know that our ratios are rad 2 over 2 and rad 2 over 2, both positive because we're positive, sorry, we're to the right and we're up. So when we look at the sign, we're really just talking about the vertical component there. So it's that rad 2 over 2, which is really just going to be 8 times 1 over rad 2. You know our book doesn't like to rationalize necessarily. So they leave it as 4 rad 2. But a better way to write that would be 8 times rad 2 over 2. And you see that the 8 over 2 reduces to 4 rad 2. So it's a more traditional way to write that out there. All right. So this problem not only had the derivative out to the third derivative, but then it had an x value to plug in there as well. So second derivatives and higher, not too bad. I messed that up. You just have to keep in mind all your derivative rules as you go, and it's not that big a deal. So that's it on this video here for second and higher derivatives. And that's it. We'll do some practice in class, and we'll be getting ourselves ready for the test. Have a good day.